You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Aerospace Engineering Podcast. I'm your co-host, Dan Blewett. On today's show, lots to cover, a lot of interesting news in the cycle this week. Number one, we'll chat about Southwest. There's just way too many flight attendants getting punched in the face, so we got to chat about it. EVTOL startup Archer is seeking to dismiss the trade secrets lawsuit filed by Wisc, but that doesn't look like it's going anywhere. That seems like it's getting only increasingly messy. We'll talk about Mightyfly, which has been cleared to start autonomous cargo drone service. They've gotten some clearance from the FAA, which will be cool. And then in our engineering segment, we'll talk about Pipistrel. They have a light sport aircraft. It's got an electric motor and about an hour of flight time with an hour charge time. So pretty cool. Some rough news by Aerospace. Their battery supplier, Oxis Energy, is facing bankruptcy. So we'll talk about the implications there. And then our EVTOL segment, lots of interesting stuff going on there. We'll talk about some certification issues, which we've talked a bunch about in the past. EHang is unveiling a longer range design, and Kellicona has thrown out a 40-passenger concept, which seems straight out of science fiction at this point. And we'll talk a little bit about that as well as some price controls. So, Alan, let's start with Southwest. It's been really sad. Southwest is calling off plans. Well, the plans to sell alcohol on the planes does not make me sad. I'm neutral to it. But there's just been a lot of incidences with unruly passengers. And more recently, a Southwest flight attendant was punched in the face, lost some teeth, and I mean, things are getting rough. What do you attribute this to?
Alcohol, people being upset about masks, reconnecting with the rest of society after being disconnected for a year. All those things are playing into it. I recently flew to Las Vegas, and I kind of like flying through Las Vegas because it's a different place. There's a little more activity going on there than most airports. The only place, I guess there's more places with slot machines. There's a couple places with slot machines in the country, but that has to have the most. And the amount of alcohol there is high, right? I mean, the people leaving the casino are going to go home for the most part. And I think you see it in places where people have been partying, and Florida had a rash of it. Some of the islands had a rash of it. And I think it's just a big problem with alcohol, people being upset about masks, people being overly sensitive about stuff, and flight attendants worried about their well-being, which they have every right to. For a 2-hour flight, you're going to get into a fist fight and punch a flight attendant, which is a federal offense, by the way. You're not going to county jail. You're going to the big house. You're going to federal prison if they convict you, and that's not worth it. There's no airline flight that's worth that. Does that make any sense, Dan? Like, does anybody realize the consequence of that? Maybe they don't. Maybe they're just inebriated enough they don't realize it.
I mean, we haven't heard that many physical, like this is a rare one, the physical, like this woman getting punched in the face. But I don't know, I guess idiots can be idiots anywhere, including in the sky. People are just like less filtered about what they're just not thinking. I don't know. It's
the FAA is issuing fines. Yeah, I think so. And the FAA is taking a much more aggressive stance.
Really expensive fines, like $50,000 I saw for some passengers.
Right. $10,000 here, $10,000 there, and like a $10,000 fine from the FAA. They're not kidding, right? When the feds do that and impose it and lock it in via some sort of court finding, they'll take it out of your paycheck forever. Like that's a debt that's never going away. They will get that money, or you're going to jail. I mean, that's what will happen in that outcome. And it's just not worth it. I know on some recent Southwest flights that I've taken, they've been trying to lower the temperature down a little bit, and some of the initial
everyone's a lot more docile when it's cold.
yeah, that's true.
No one's fighting when they're shivering. But if it's real hot in there, and that's a very real thing. I mean, you wonder if this summer, the first summer back from COVID, where it's still iffy with masks here in DC. Like some businesses allow them if you're vaccinated, or allow no mask if you're vaccinated. Many are still not. Many people are still wearing their masks despite being vaccinated, and in a business that allows them to not wear one, which is baffling. But if it's like 95 degrees and people are angry about masks, or just, I don't know, this summer could be like the summer of fistfights. Well, unfortunately, I hope not.
Yeah, well, it does make you wonder, because wasn't the Department of Transportation over the weekend said they wanted people to wear masks on airplanes just because it's the right thing to do? Like, that's not the reason why you wear a mask on an airplane. You wear a mask on an airplane because there is some health implications. Just like when we started it, there were some health implications. You want to make sure that wasn't some sort of outbreak that was due to aircraft and people moving around. Awesome. But that is essentially over. At some point, you're going to have to release that. Otherwise, you're going to continue to have flight attendants assaulted. I mean, that is the reality of the situation. You will have flight attendants assaulted, and the penalty for it is not connecting to some random person who doesn't read the FAA website about the fines and maybe has a drink before they get on the airplane. Whammo. Those situations can escalate so fast. And you just feel bad for the flight attendants who are stuck in the middle. I mean, they got an employer that's telling them one thing. They got the FAA. It's telling them you got to do these certain things. And you got passengers that are tired of it. It's inevitable.
Yep, we're all tired of it. But be nice to your flight attendants, everyone.
Yeah, come on.
So Mightyfly has gotten FAA approval to start doing some test flights with its hybrid electric autonomous cargo EVTOL aircraft. Quite a mouthful. Good reporting from futureflight.aero. But they're going to be seeing if they can deliver these reasonable payloads, maybe 100 pounds here or there, up to 600 miles. Alan, what's unique about this little special airworthiness certificate?
Well, it's part of a program that the FAA started a couple of years ago to apply what they call Part 135 regulations, let's call them, conditions of operating a paid for flight, like a air carrier kind of thing, which has never been envisioned in a sense in the regulations of you have a pilotless aircraft. It's not necessarily pilotless as there's not somebody on the ground controlling it, but there's not somebody in the aircraft. That's the difference. Now, when I looked at the pictures online, you're like, this is not your average drone. Like, this is the size of a small car.
Mm-hmm.
It's decent size. Anything less than 100 pounds and goes 600 miles is going to be big. And I understand the rationale why we want to do this, but I don't understand the rationale why we want to do this. Like, what can't we carry right now, airport to airport, on an aircraft? I mean, even if it's an unpiloted drone thing, is the intent, at least what I was reading through this, is the intent to basically drop cargo in some random place as needed, not actually go to an airport and land the thing? That bothers me. That part bothers me, because the most critical part of any flight is landing, or in some case deploying cargo. And when something goes wrong there, I'm not sure how great that's going to be in terms of people on the ground and property on the ground and what it looks like. Because can you imagine? I mean, Dan, you order some 99-pound Amazon product and it comes delivered to your front door. I don't know how that works.
297 boxes of macaroni and cheese. Bought at a discount from Amazon. Delivered to my door. Looks like they would fit. Yeah.
What's the economics of that? I don't think that makes any sense economically to do that when they have the postal trucks going by your place every day anyway. Yeah. I don't know. That makes a lot of sense. And the downside risk is that this craft falls out of the sky or hits something or runs into something and poof.
Well, I feel like it kind of goes back to your point there. I feel like it kind of goes back to the idea of whole truckload versus these small shipments, right? Like if you can ship a whole truckload of something, it becomes way more economical than shipping one off, right? This is a
Absolutely.
Something. What was I reading? Something about a carpet manufacturer. They were trying to become more eco-friendly, and they were trying to recycle their carpet, but like tearing carpet out of a commercial building and shipping it back to their factory was just super duper expensive. So they started to create caches where like you could have a local warehouse until it got to a full truckload of this used old carpet. Then they could pick up in a whole truckload, and then it made economic sense. So, that kind of just was in my head as you're just talking now about the economics of these little, very high tech, small shipments. Like you said, if you can throw all these packages on one UPS truck, how is that not more economical? I don't know. Probably not as fast, depending on, whatever, but yeah.
I get the one. There was one drone service that's operating in North Carolina in some mining conditions where they wanted to move equipment like across a mountaintop to get from one mine site to the other mine site. That totally makes sense to me, right? I mean, that's not. It's in a rural area. You got equipment that's very difficult to get it from A to B because there's a mountain in the way, and you can just basically jump over the mountain with the drone. Okay, but delivering macaroni and cheese makes no sense. No one's gonna. I just don't see it.
That's what I want. Okay.
Well, whatever Jeff Bezos can deliver, it will be, authorized, I guess. We'll see.
So moving on to our engineering segment, let's talk about conventional takeoff airplanes. There's just so much news about in the EVTOL sector. It's just everywhere. But today, let's talk about the Alpha Electro, which is a light sport aircraft from Pipstrel. It's got about an hour of flight time, and it only takes about an hour to charge, which is pretty cool. And so this is another one of those, new technologies using electric motors, pretty efficiently. I mean, that seems reasonable that if you're training a new pilot, even being on the ground for an hour to recharge doesn't seem like a big deal, as you're probably getting ready for the next student and, going through some checks and all that stuff. And of course, obviously the battery technology will increase, and increase that flight time over time. But, I mean, Alan, where do you fall on this use for light sport aircraft? Because I know you have some concerns about weight, as they're already really light. I mean, hence the name. But heaviness and the weight has something to do with the safety of the aircraft, doesn't it?
Yeah, the accident rate for light sport aircraft is not very good. And the thought was that taking some of the more restrictive regulations away and simplifying the approval process for light sport aircraft would open up a whole new marketplace for less expensive aircraft. That hasn't happened in the way they envisioned it. The aircraft are still expensive. And when I say expensive, like the price of a house. It's expensive. So an aircraft is expensive to make, period. Let's get that on the table. The other part about light sport aircraft, from a safety standpoint, is that they're light and they get tossed around a good bit. And I think that has something to do with the accident rate that they've seen, because they just don't have a lot of mass there. But I think the concept is right. I think the electric concept and the battery concept and the recharge capability is right. The operation costs are way lower because of the electric motor and the battery, just a simplicity standpoint. It's just a lot less to take care of. So if you have a training facility and you want to keep your operating costs low, that's how you do it. You start putting electric aircraft in there because you're not going very far on and it's some sort of training run. You're just not, and that's sort of the perfect marketplace, right? It's about that discussion from a marketing standpoint. You want to niche down and find that sweet spot where your product works, and you can be the expert in that one thing. Well, Pipistrel's kind of starting to own that space a little bit because of the technology they're bringing forth and the electric aspects and lowering their operating costs and doing all these other things. I think it's a cool airplane. I think they're going to be successful with it. They already are successful with it because you see it being shown in multiple different countries. You see a lot of interest in it. It's going to stick around for a little while, it looks like.
Yeah, and what I thought was cool is I watched a YouTube video about it, is that, because it's electric, like the torque curve is so fast that it's getting up to speed and take off like really, really fast. Yeah. Which is the same thing with like Tesla automobiles. I mean, they're so fast because you put the accelerator pedal down, not the gas pedal. And it's just like all the engine's power is there immediately. So that's a pretty cool thing. Yeah.
Yeah, infinite torque. Yeah, that's the beautiful thing about electric motors. Yeah, but I think it's also going to take some time for pilots to get used to that effect. A lot of engines take time to spool up. They're not instantaneous, and in electric aircraft you can get away with a lot more. And the other things that you don't have to worry about is like carburetor icing and all the associated problem failure modes that occur with a piston engine go away with electric. And if you will at some point, the goal is to transition up to a larger aircraft. For most pilots, is to move up to a larger single, then to a twin. You have to learn those other skill sets because the electric aircraft is really simple to operate, which makes it great for a trainer, but not necessarily great for moving into like the twin world yet.
Yeah. Well, speaking of twin engine, Oxis Energy, which was the battery supplier of lithium sulfur batteries for all different applications, is facing bankruptcy, which is unfortunate for the by Aerospace E-Flyer 800, which is the 8-seat electric dual prop plane that by Aerospace is developing. I mean, Alan, do you feel like this is going to be a quick, just grab another supplier? I mean, I think the one positive for buy is that there's a lot of battery power needs in the world at the moment. So I'm sure there's someone else out there, right? Maybe? Or is this going to be a problem for them?
The sulfur part of that battery was the trick, and I think that was going to increase the energy density by roughly a factor of 2. So that was the whole value to that battery system, and why it was chosen is it's all about energy density and weight, right? So you can get more energy packed in that same amount of volume, then it works great for airplanes. And if you're trying to make a twin engine aircraft like a King Air, you're going to need a lot of energy to make it go far. So the pairing up of Bi and Oxis made a lot of sense at the time, but it's starting to feel a little bit like Oxis knew this was coming. So the most valuable time, or the time to extract the most value for your company in an aircraft environment is to get an aircraft design wrapped around you, then say you're going to file bankruptcy. Because the aircraft manufacturer feels like they're getting stuck. Right? They're in a really bad position, and that maybe they'll buy you, and maybe they'll overpay for you. Because the option which Oxis is trying right now, and what you hear a lot of reports is that they're offering all their patents for sale. Now, you haven't heard anybody buying them, but they're going to offer them for sale. And if you're buy, you're going to have to worry about that. Like, well, maybe Textron buys all their patents, and I don't have my batteries for my airplanes anymore, which Textron could do, right? I mean, Textron could really, at this point, put a big dent in the 8-seat twin that Bi wants to make. And so there's a lot of that business aspect. And as engineers, you don't really think about those avenues that happen, but it's still, at the end of the day, it's still business. And if Oxis thinks they can get a big value for their corporation or get cash out of it and cease operations, and that's the right financial thing to do, then maybe that's the right thing to do for that company. But it does have ramifications much larger than their company. It does. And you see it in aerospace quite a bit. You got a supplier locked in, and then they try to leverage you for cash so they don't go bankrupt. And Boeing's been in that situation a number of times over the years, and it just turns ugly. There's really no good outcome of that. Boeing at times has taken over companies so to keep them out of bankruptcy and then continue making parts so the airplanes still run on the production line. But you don't want to be doing that. If you're a smaller aircraft company, you don't have the people to do that. And so it does hurt schedules with Bi on the twin. It has to, which is a shame, because I think there's a lot of great things going on at Bi right now. There really are. The trainer, the 2-seat and the 4-seat trainer make total sense. And I think those airplanes are going to be great airplanes once they get them out and delivered.
Well, and one of the things that Bi was looking towards was that 550 watt hours per kilogram density that Oxis was hoping to get to by 2023. And this was a good article about this on EVTOL.com. And so now I guess, like you said, they've got to re-steer the ship and figure out where they can maybe get that future energy density, because it doesn't sound like that's on the market, the way that they're trying to develop that. And that's, I think, the big challenge is companies are trying to get ahead of that and say, okay, we want this target in the future. What companies are doing that? But if they're startups, they're just going to be subject to this riskier environment where, yeah, they don't have a lot of orders. They're developing a lot of new technology. They're doing a lot of research. They need a lot of investment money without a lot of orders coming in. And that's that troubling, I don't know, that it's difficult.
Yeah, and Dan, it's very similar to if you see, there's been a lot of piston engines being built for smaller Part 23 aircraft for over a number of years, and how unsuccessful those programs have been on just a standard internal combustion engine where they just don't make it, right? And why would electric motors and batteries be really any different than the internal combustion engine, which we've known for 100+ years how to make work? All the time, new engine programs come, new engine programs go, and you just scratch your head like, I don't know why they couldn't get this motor to work. And I think the same thing exists here. The problem for an aircraft manufacturer is sort of twofold, though, right now. Before, you got fuel, liquid fuel, which you can buy any airport anywhere. So that problem solved on a typical internal combustion engine. It's just the motor part you got to go figure out. On electric, you got to get the batteries and the power plant, the electric motor. You got two big problems instead of just the motor problem, and that it adds to the level of complexity and difficult to the engineering staff is what it does.
So let's move on to our EVTOL segment today. First, let's talk about certification. So, Alan, there's a good article from aviationtoday.com just talking about where some of these companies are. Joby Aviation is one of the first. They got military airworthiness from the AFWERX Agility Prime program. Right. That's still a far shot from FAA certification.
Yes.
We'll spend a couple minutes here, but what are the big keys here? Because this article says that Archer, for example, will use a blend of current FAA Part 23, 27, 33, 35, 36 requirements. Right. That sounds, I don't know what that means, but that sounds complicated.
Sounds, impressive, right?
So, yeah. So take us through some of the hurdles here.
Oh, I mean,
okay, just all of them, all the hurdles. Alan has spoken.
I think in the eVTOL market there are so many that it gets hard to even break it down into bite-sized pieces. And I think as engineers, one of the first things they teach in engineering school. One, to do your homework, and two is to break down problems into bite-sized pieces so you can solve each part without having to solve the whole thing at one time. And the problem right now for a lot of eVTOLs is that they have 23, Part 23, Part 27, power plant, propellers. So they're touching all these different areas that a typical aircraft company like a Textron won't touch. Like Textron doesn't make props, or hasn't made props in a long time. Textron doesn't make motors. At least unlike in the Cessna or the Beach lines, they don't. They buy them, right? So there's two of those off the table. They can just buy a component. And now the eVTOL's got two more left, which is that it's part helicopter, part aircraft. And so you got two sets of regulations, one for aircraft, one for rotorcraft, that you have to meld together to make this set of regulations or requirements for this aircraft, which really no one has ever done before. So sometimes those regulations don't necessarily jive the way you think they would. There's got to be some interpretation to them. There's got to be some learning that goes on, but it's just a massive amount of complexity you've added to it because, in my opinion, because of the vertical part. The vertical part adds a lot of cost and complexity, weight cost, material cost, you name it. It's adding a lot of complexity to the aircraft, where like a buy Aerospace doesn't have to do that. Buy's going to buy a propeller, I think. Seems like it. They're clearly buying Safran motors. I mean, that's been announced multiple times. They're just building an airframe. So Buy's just building an airframe. A Part 23 airplane, of which we've been building Part 23 airplanes for years. So Buy has a much smaller bite-sized problem to work on versus Joby, which has multiple problems to work on. That's the difference. And so from an engineering standpoint, you need to look at how many my opinion. You need to look at how many people are on staff to solve all those problems, because everybody's working on the bite-sized chunk, and there's only so many people working on bite-sized chunks. You need a lot of people chewing a lot of time. So the amount of overhead, amount of people at a Joby ought to be 2 to 3 times as many people as it by. Has to be, to make it go.
Well, let's stick with this line here. So as far as engineering and trade secrets go, there's a pretty contentious lawsuit right now between Wisc and Archer. Of course, what lawsuit is not contentious? But this one is getting, it seems a little messier. The FBI is involved. Archer is saying, which I feel like this word is used in every lawsuit, which is baseless. Everyone just calls them, oh, this lawsuit against me is baseless. Well, some of them are, but this one seems like it's not going anywhere any soon, or anywhere anytime soon. It seems like it's only heating up. Alan, what are some of the, without getting into the specifics, because there isn't that much known, there's definitely some similarity, which is what Wisc was claiming when some of their many of their engineers were hired to go work for Archer. You can definitely see some of the design potentially incorporated with Archer's aircraft, but what's the big code of conduct here for engineers? I mean, you're an aerospace engineer. What warnings and what code of conduct would you share with a young engineer to not end up in a situation where they might be in trouble doing something like this?
In today's world, when you sign on to a company to work for them as an engineer, there's rarely a case in which you're not signing a confidentiality non-disclosure agreement that lasts for years after you leave the company, if they're smart. And they may even have to sign a non-compete. Now, non-competes tended to be back in the 90s, not so much today, where you couldn't work for a competitor for a year. So basically you couldn't eat for a year, or couldn't work in a similar industry, because everybody's a competitor in airplanes. Who's not? Yeah. So you'd have to go homeless for a year while the clock ticks away. You as an engineer have to make really good decisions here. If you're signing that non-disclosure, that means they're going to hold your feet to the fire, and there's some corporate lawyer who works for the company who's going to come after your rear end if you decide to, in theory, take things out that belong to the company. They're paying you not to do that, and that's the company rationale. Is like, I'm paying you not to steal our stuff. Don't steal our stuff. And as an engineer, you're like, well, there's a fuzzy line between what's yours and what's my intellectual property. It's my head. I own what's inside my skull. You don't own that, right? And was it, well, everything you wrote down, everything is written down or on a computer somewhere, we own. Any sort of public information you made in a meeting or whatever, they own. So you have to know that. And as you get older and more experienced, and you're coming through the ranks of stuff, you have to realize there's a point at which maybe the compensation you're getting for the ideas you're creating isn't compatible with you anymore. So you have 2 choices. Swallow it. Give your company that's paying you a weekly salary, give them the idea and move on. Let it go. Or if you think the idea is so grandiose and worth so much money that you're going to set the world on fire, then you better shut up and not tell anybody about it and leave. Give it a couple of weeks, start your own company, go to work for somebody else who's going to pay you for what that idea is worth. Those are your options. What your options are not is downloading a bunch of documents off of this company A and then going to work for company B and giving them all the information. Now, company B ought to be smart enough and have corporate attorneys too to say, you can't do that. We're not looking at that stuff and you're fired. Get out now. Like, you got to go right now because you're going to get sued. And rightly so, you're going to get sued. But engineers fit this weird place where their intellectual property, what's in their head, what they consider intellectual property, because it's me, shouldn't get abused. And if I'm working for a company that doesn't, maybe the idea is not getting promoted, or the company doesn't have the money to invest in this properly, and you feel like your idea is withering on the vine, you have this gumption like, well, screw it. I'm going to the next company and take this great idea, and I'm going to get paid for it. It's too late. It's just too late. You just can't do that, because company A is going to sue company B, and you're going to be in the middle of it. And no matter what happens to company A or company B, you're going to be unemployed. And not only going to be unemployed from company A and company B, pretty much companies C, D, E, and F, and G are never going to hire you because what you did there. So it's a good lesson for everybody just to not do that, and to figure out, get an attorney, honestly, swear to God. If you think you're in that situation, get yourself an attorney and talk it out with somebody who knows what they're talking about and what that corporate law is and what you're allowed to do and what you're not allowed to do. I did that early in my career, and it was probably one of the best $200 I ever spent. If you have a great idea and you don't think their company you're working for is going to have any value in it, then quit. Just quit. Don't tell them about it. Quit. Move on to someplace else. And I think that's a much more valuable experience and knowledge to have somebody on the outside, rather than you or your spouse or whoever, your friends, giving you advice. You better get you an attorney, someone who knows about corporate law and how you're going to get sued, and get it figured out before you decide to walk out of a company, because that's trouble.
Yeah, well, we'll see how this story progresses. Both sides are debating the facts, and we'll see what comes down to the air.
Yeah.
So last on the docket today, we won't go into detail on the one, but EHang's got a long range. It's their VT30 EVTOL design. Still pretty preliminary, but they're already looking at a longer flight.
Right.
Or just more passengers in general.
More passengers, right.
More passengers. Yeah, this is still actually going to be pretty short. So maybe a 35 kilometer, 22-ish mile range. So yeah, I mean, they're still building off their thing. They're still, I guess, kicking after the the stock turmoil a handful of months ago. Right. They're still plugging along. The other thing I find is interesting here is this company called Kellicona is just sharing their prototype sketches of a 40-seater EVTOL aircraft that looks like a flying manatee with ducted fans. I mean, that's what it looks like. There's no getting around it. So while most EVTOL companies are struggling to make this work with 2 seats or 4 seats, this company's like, hey, we're going to do 40. Like, move on over, everyone. I mean, Alan, is this as outlandish as it sounds?
Yes, it is. I mean, the image is in like you're in this can. It looks like an airfoil with no tail on it, no empennage on it at all, and a bunch of ducted fans that's providing all the directional thrust. And I think that's just not going to happen. I don't know how else to describe it. That's not going to happen. You're not going to get 40 people to get inside this enclosure, I'll call it. You're not going to be able to certify it. It's not going to... Everything about the physics of this says no. And also the human response to it and human emotion to it's going to say no. So why are we pursuing this, and why are people... I guess we got to fill space on the internet. There was a slot on the internet available for some crazy airplane, right? This is the day. Every Thursday we got to put another crazy airplane. And that's not crazy, but like a maybe unrealizable airplane design out there, and keep all the readers interested. This is another one, and it just seems like now. It used to be they were like nuclear powered aircraft that were going to go Mach 5, and then it transitioned into super efficient big jet engines, and then we transitioned into electric, and then it seems to like fluctuate, and then the solar powered airplanes and the whole thing. So we go to this like gyration thing where it's like the old popular mechanics of days gone by, which was, they'd have stories that would just not, there's no way these things are going to come to fruition, but it spark interest and keep creativity happen. I think when you see designs like this, it's like, oh, well, okay. I mean, there's some pluses, there's some minuses.
Oh, that's fun.
Right.
Yeah,
right. You're not saying to yourself, man, I got to call my stockbroker and invest in that airplane. Don't do that. No, don't do that. That's exactly the opposite of what you want to do. You want to hold your cash in these situations. But I think from an engineer standpoint, you're like, oh God, come on, no, and maybe prove me wrong. It's like we were talking about. Maybe we need to have a predictions part of this of the podcast for on the airplane side, where you say yes or no, and then we put it in an envelope, and a year from now we open it up and go, okay, Alan was right 62% of the time, and
yeah, a little time capsule.
Right. It feels like it because it's so wild right now that it's just like Tesla 5 years ago, like, oh yeah, maybe they won't make it. Or all the Starship stuff that Musk is doing. You're like, oh, there's no way. And yeah, they pulled it off. Awesome. But I do feel like we're in this weird prediction mode. We should do something like that. It'd be fun.
Well, it's just again, seeing all the struggles that companies are having to put their aircraft in the air with just 2 seats, and then to see this 40-seater, and then to look at the company's website. Yeah. And see no faces on their about page. There's no people listed there. There's no head engineer. It's unclear what this is. I mean, who are these people? I don't know. How much money has any money been invested in this? Those are also unanswered questions. I couldn't find any.
That's a really good point, right? I think it's a very good point. Is it a SPAC play?
It could just be a graphic designer made some renderings of a plane, and they made a website and said we're going to do 40 seats, and that's as far as they've gotten. We don't know. I mean, good luck and Godspeed, but there's not a lot of information besides the renderings and what they hope to have happen.
Well, over the pandemic time, I was reading a really interesting couple of articles talking about the evolution to SPAC and how that structure is set up, where it's like going to Vegas. So there's been a lot of SPACs set up. But they can only live for a certain amount of time, and you're never sure which one's going to be the one that hooks up with a corporation that has a possibility of making a big product. And you kind of wonder if a lot of if you want to tap the SPAC environment right now, that would be the way to do it. Like, oh, I got a SPAC to invest $100 million. Of which we're never going to spend, but it can keep me in, nice lunches and an office for the next year or two. That's what it seems like. It doesn't seem like there's a financial, a keen financial sense that goes along with the engineering and some of these projects where they're going to really come about and make something of it.
Yeah, we'll see. But you're right. It's kind of the Wild West of designs and new things. And like you said, it's probably good just to get the creativity flowing. But who knows if we'll ever see this design come to fruition. So that's it for this week's episode of the Struck Aerospace Engineering Podcast. Thanks so much for listening. Be sure to subscribe on YouTube, iTunes, Spotify, Stitcher, wherever you listen to podcasts. And share the show with a friend. Leave us a review. We'd appreciate it. And we will see you here next week on the Struck Podcast. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.